Okay, so this is question number 4 for learning target 1. In this question, it tells us that one pipe can fill a pool 1.25 times faster than a second pipe. Then when both pipes are open, they fill the pool in 5 hours. How long would it take to fill the pool if only the slower pipe is used? That's the question we're going to answer here through the work, rate, and time problem. Okay, so in this problem, we've set this problem up already. So, the number 1 that's in the numerator here represents the work being done. So in this case, it's representing one pool that's being filled. The denominator in this problem, which in this case is the variable p, represents the amount of time that it's going to take one pipe to fill up the pool. So that's what our p is representing in this problem. You add this to one pool over 1.25p, because in the problem it specified that one pipe, which would be this one, is 1.25 times faster at filling a pool than this other pipe. So you'll have 1.25p in the denominator here. All of this is set equal to 1 over 5. The numerator again represents the work being done, which is one pool being filled, over the time it takes for it to be filled when both pipes are open, which is 5 hours. So now, to start simplifying this problem, you're going to want to cancel out all of the denominators. To do that, you need to multiply by all of the denominators. So we're going to multiply by 5p times 1.25p. This will cancel out all of our denominators. And to reset this problem, you're just going to put 5p times 1.25p in the numerator of each one. So the first one will be 5p times 1.25p over p plus 5p times 1.25p over 1.25p equals 5p times 1.25p all over 5. Now, we're going to want to start simplifying this. So what you can do is you can look for common variables or numbers that are in the numerator that are also in the denominator. So for this first expression, 5p times 1.25p over p, we can cancel out p, which will leave us with 5 times 1.25p. Next, we can cancel out 1.25p from the numerator and the denominator in this expression, which will leave us with positive 5p. Lastly, in the equation 5p times 1.25p over 5, we can cancel out the 5's, so we no longer have a denominator, and we get p times 1.25p. Now, we need to simplify this a little bit before we can start combining numbers. First of all, we can multiply 5 times 1.25, and if you do that in your calculator, you'll get 6.25p plus 5p equals p times 1.25p, which in this case would be 1.25p squared. Now, we can combine like terms where we have p, and we can get 11.25p equals 1.25p squared. Now, we can subtract the 1.25p squared so that we have all of our terms on the same side, and we're going to have a quadratic equation, so you want to get all of them set equal to 0. So that leaves us with negative 1.25p squared plus 11.25p. So now that we're left with negative 1.25p squared plus 11.25p, the easiest thing to do here is going to be to use the quadratic formula, because factoring it is just going to be a mess. So, you remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So, in this case, we'll substitute all the values where this is a, this is b, and c would be the value that is not multiplied by a variable. In this case is 0. So that would be C. So now we're going to take negative b, which would be negative 11.25 plus or minus the square root of 11.25 squared minus 4 times a, which would be negative 1.25, times c, which is 0, all over 2a, which in this case would be 2 times negative 1.25. Now, we're going to start simplifying this area inside of the radical. So, we still have negative 11.25 plus or minus. This would be negative 4 times negative 1.25 times 0. So obviously when you multiply anything by 0, it's going to become 0. So all of this is going to cancel out, and we're going to be left with 11.25 squared. And now you may wonder why I'm not simplifying 11.25 squared. But you'll see why, because we have a square root. So it's going to be very easy to cancel it out and get our number back. And then 2 times negative 1.25 would be negative 2.5. Okay, so now, like I said before, we made our job really easy by getting 11.25 squared, and that's the square root of that, which would just simplify to 11.25. So we have negative 11.25 plus or minus 11.25 over negative 2.5. So, we can simplify this answer. And obviously, if you have negative 11.25 plus 11.25, that's going to be 0 divided by negative 2.5, which will just simplify to 0. So, that's not going to be our answer because we're looking for a unit of time. And it has to be a positive number. Otherwise, it isn't filling it, and this isn't telling us anything. So 0, one of our answers will be extraneous. So the answer we're going to want to focus on is going to be negative 11.25 minus 11.25 over negative 2.5. And this will simplify first to negative 22.5 over negative 2.5. And lastly, this will simplify, the negatives cancel out, and 22.5 over 2.5, if you do that in your calculator, it comes out to a nice even number of 9. Now, you may think that we're done here, but that is not the case. We have that p equals 9. But if you will remember, in our original problem, the question asks us, how long would it take to fill the pool if only the slower pipe is used? P, in our situation, represents the faster pipe, because the question says that one pipe can fill a pool 1.25 times faster than a second pipe. So, to get our final answer, what we need to do is we need to multiply 1.25 times 9, which was our value for P. Once you multiply that in on your calculator, you should get 11.25. So in this case, we can say that this pipe, the slower pipe, fills the pool in 11.25 hours. And that is your final answer.